Hi guys, it's Miss Griffin. We're looking at Unit 2, Skill 4 on end behavior. So here's your essential question. Take a minute to write it down. It says, how do we determine the end behavior of a function? And then you're going to complete this reading. So I want you to make sure that you are reading and highlighting important information. And then we'll come back together and talk about some important key pieces here. Okay? So pause your video, go ahead and read, and then we're going to go over it together. Okay, so I'm going to go through this little piece step by step. It says that the end behavior of a function describes how the y values act as x approaches positive and negative infinity. Or we can talk about how the graph heads out to the right and to the left, far away from the origin, and talk about how or where the function goes from there. The next part that I chose to highlight was this little box here. It says as we go to the left-hand side, meaning x goes to negative infinity, because remember that a number line looks like this. This way is negative infinity, and then this way is positive infinity. So as we approach negative infinity to the x's, then the y's look like they are approaching y equals 3. So I go to the left, 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 and then this graph is still rising, but then this asymptote acts like a ceiling to this graph. This is important for you guys to know. Asymptote is like a ceiling. We can't go up above this ceiling. Or it could act as a wall if it's vertical. Okay, a vertical asymptote or a horizontal asymptote acts as walls or ceilings. You can't go past them. X is not defined in that particular value. All right, so if I keep reading on this other side, it says that as we move to the right side, as x goes to positive infinity, then the graph seems to be approaching or leveling off at y equals 3. So same idea, as I go down towards the right, to the right, to the right, to the right, as x goes to positive infinity, y, the function, is going to stop at this now floor, in this case because we're going downwards, at y equals 3. So then you'll notice that these two little things say that we would write this mathematically here and here. As x, and then that arrow, as x approaches negative infinity, f of x goes to 3. Another way to write this is as x goes to negative infinity, y goes to 3. Okay, so f of x and y mean the same thing. All right, we're going to see another example here. You should have already seen it because you were reading ahead and highlighting. So in this second example, it says that as we head to the left, so that's why I have this little left arrow, as we head to the left, then the function itself is going up, up, up forever and ever because of that arrow. So x goes to negative infinity, then f of x, or y, goes to positive infinity. So as we go left, the graph goes up. So maybe you want to write that sentence below here. This really means as we go left, the graph goes up to positive infinity. And then this left means negative infinity. Same idea on the right side. As we move to the right, the graph is going downwards forever and ever and ever. So this is the mathematical way to write it. You have to know that, but you also need to understand what it means in real life words. As we go right, and of course that's to positive infinity, the graph goes, in this case down, to negative infinity. All right, flip it over when you're ready. So here we just have a couple examples to describe the end behavior. There's 4 of them in total, and then you're going to write your summary. So it says determine the end behavior for each of the functions below. So this here, PS, is your basic setup that you have to memorize. Basic setup to memorize. As x goes to a number, y goes to a number. So here in this one it says as x goes to negative infinity. Remember that this means as x goes to the left. So as we move left, where is the graph going? Well, this one is going up to positive infinity. As we move to positive infinity for the x's, so as we move right, where is the graph going? Well, the graph is going up to positive infinity. These can match, or they don't have to match. It depends on the actual graph. There's no rules here. You just have to say, as I move to the left, the graph goes here. As I move to the right, the graph goes here. All right, this next one is x goes to negative infinity, so again, that means to the left. So as we move left on this graph, the graph, ooh, look at this asymptote. So I'm going to write that in, this little asymptote. At y equals -4. So then the graph has to stop going up at y equals -4. I can't go any higher than this ceiling right here. Okay? And then as we move to the right, x goes to positive infinity. As that happens, the graph again stops at y equals -4. All right, part C. As the graph, or as x goes to negative infinity, so as we move left, where's the graph going? Looks like it's stopping at 0. It's not rising above 0 at all. As we move to positive infinity for the x's, so as we move right, the graph is going to 0. Okay, next one, as we move to negative infinity on the x's, as x approaches negative infinity, so as x goes to the left, where's the graph going? Here's the graph. It looks like it's going down to negative infinity forever. As we move x to positive infinity, so all the way to the right, as we move to the right, your graph is going to positive infinity for the y's. It's climbing, climbing, climbing. Something I do want to say is that x does not always have to approach positive and negative infinity. So there's these graphs that you might see that might look like they might look like this, something like, okay, so that's the graph of a square root function. It's on graph paper, and these two values here would be, I don't know, something like 6 and 5. I'm just making these numbers up. On a piece of graph paper, you would actually just count. So we would not set this up as x goes to negative infinity because x has to stop right here. There's essentially an asymptote. Okay, it can't go any further. So what we would say is as x approaches 6 from the right. So as we move to the left, we're approaching 6 from the right side is what this is saying. I'm going to just like circle this little plus sign and identify what this means. Approach 6 from the right. Okay, so as we approach 6 from the right, y approaches what number? So as we go this way to 6 on the x's, where does the graph go? Well, it goes as low as 5. Okay, and then the other way, as x goes to, well, we don't have to approach 6 from the left, we just have to keep going to the right, positive infinity. Then y goes to, in this case, the graph is going, as we move right, we move up. Very slowly, but we do it. Okay, so this is like another example for you, part E, maybe, because you might see this on your practice, or on a CFU, or just in life in general. Okay, take a few minutes to fill in your summary. Don't forget to answer those questions. Make sure you understand them, and then you're going to your practice problems. All right, adios.